In this tutorial, we are going to talk about matter and its properties and changes. Matter has both physical and chemical properties and can undergo both physical and chemical changes. We're going to talk about both of those in this video, but we're going to start with physical changes first. So let's start there. Physical properties are characteristics of matter that can be observed without changing the identity of that matter. For example, we have this diamond right here. So there's this diamond. We can talk about its physical properties. So this is things we can observe about this diamond, that when we're done making that observation, that diamond is still a diamond. So we can talk about its hardness. We can smash it with a hammer or any number of things and see how hard it is. When we're done, it's still a diamond. We can talk about its luster, how shiny or dull it is. We can talk about how its density is, like how dense it is. We can measure its density, and when we're done, it's still a diamond. We can talk about its odor, which, it doesn't really have an odor, but we could talk about the fact that it doesn't have an odor. We can talk about its color. We can talk about its electrical or heat conductivity. We can have a conversation about its texture. We can try and melt it and talk about how hot it has to be to melt. So what's its melting point? So I guess the point is that all substances, all matter has physical properties. And these physical properties are just things you can describe about that thing that doesn't change what it is. When you're done making that description or doing that test on that thing, it's still the same substance. Physical changes of matter are changes where the substance undergoes a change and might look different when you're done with it, but it's still the same substance it was before. So here's a couple of examples. So the first example I have here is shattering glass, right? Yeah, it looks different when you're done because it's in smaller pieces, but it's still glass. And then the second picture is a solid that I've just, shown a picture of it being crushed into smaller pieces. So even though you crushed it and it's in smaller pieces, it's still the same substance, it's just smaller pieces. Or water melting. I mean, water, when it's solid in the form of ice, looks different, but then when you melt it, it's a liquid, but it's still water the whole time. So examples, all phase changes. All phase changes. So solid to liquid, liquid to gas, in reverse. So evaporation, condensation, all of those. All phase changes are physical. Because when the substance is done undergoing the change, it's still the same substance. Breaking or cutting something. So we'll say breaking, cutting, crushing something. Dissolving. So if you take something like, say, sugar, and you put it in water, and you stir it around, it's still sugar and water, it's just mixed together, and it dissolved, it's still sugar and water, so it's a physical change. All right, let's talk about chemical changes and properties. Okay, so chemical properties of matter describes a substance's ability to react and change into another substance. So whether or not a chemical is flammable, for example, flammability describes a reaction that a chemical can undergo that would then turn it into another chemical. So whether or not something's flammable would be a chemical property. And flammability actually describes a substance's ability to react with oxygen to produce heat or flame. Another example of a chemical property is, reactivity with acid. So some substances, some metals like copper will react with, iron, things like that, will react with acid and actually produce new substances, whereas other chemicals or other substances won't. And that describes their chemical reactivity with acid. So chemical changes of matter are changes that matter undergoes that actually change the identity of the matter. So we just talked about flammability and whether or not something reacts with oxygen. So what's really happening when something is flammable is this. So for example, this is methane. So what I have here in my methane molecule is I've got carbon in the middle surrounded by 4 hydrogen, and they're all bonded to each other. And then this is oxygen, and in fact I have 2 oxygen molecules. So this is an oxygen molecule and this is an oxygen molecule made of oxygen atoms. So what happens when a methane molecule and 2 oxygen molecules react with one another to and what does it really mean that methane is flammable, which means it reacts with oxygen? So what happens is when these things come in contact with each other, we end up getting a little rearrangement of molecules. So you get 2 of your oxygens meeting up with your carbon and forming CO2, carbon dioxide. And then what you have left over, you've got an oxygen will bond to 2 hydrogens, and then of course you have another oxygen that will bond with the other 2 hydrogens, and what you'll end up with is 2 water molecules. And those chemicals just underwent a chemical change. They are no longer methane and oxygen. The bonds broke between the atoms rearranged, and you now have carbon dioxide and water. So that's a chemical change. So you had bonds breaking, atoms rearranging, new bonds forming, and therefore you got new substances created from all the pieces from the old substances. This is a chemical change, also called a chemical reaction. So chemical reaction is another word for a chemical change. And just FYI, something being flammable and burning is not the only chemical change that something can undergo, or the only chemical change that you'll find out in the world. For example, rusting. So when iron turns into rust, that's a chemical change. When you mix vinegar and baking soda and it gets all fizzy and bubbly and foams over, that's a chemical change. Those little glow sticks that you get at, Halloween or whenever when you go to parties, those glow sticks are a chemical change because they produce light that wasn't there before. I think the important thing to remember is that a chemical change always results in new substances that weren't there before. Now, how are you going to know? How do you know? Sometimes it's hard to tell. Sometimes, how do you know if a chemical change occurred? Well, there are actually signs. Okay, so the signs of a chemical change are as follows. And it should be noted that not every single one of these things has to be observed for a chemical reaction to have taken place. Just one of these will indicate that a chemical reaction has occurred. So the first one is color change. And so in this picture, I have a piece of copper wire. So this is copper wire. And I'm putting it into a solution of silver nitrate. And I'm letting a reaction take place. And as that reaction takes place, the solution starts to turn blue. That's a color change. You went from having something that was copper colored and colorless to something that's blue. Another indication that a chemical reaction or a chemical change is taking place is the formation of a gas that wasn't there before. So in this picture, we added a piece of metal to some solution and it started to fizz. So formation of a gas is often seen as either fizzing or bubbling, and sometimes it's just plain old fumes or smoke that didn't exist before. Yet another indication that a chemical change is occurring is the production of light or flame where there wasn't light or flame before. So when you burn a piece of wood, it produces a lot of energy and it also produces a flame. Or those glow sticks that I spoke of earlier, when you crack them and shake them, it suddenly produces light that didn't exist before. And that's because both of these are producing new chemicals, and those chemicals, in the process of being produced, are giving off some energy in the form of light. Another sign of a chemical change is the production of a precipitate. And a precipitate can be pretty confusing if you don't know what it is you're looking at. So here I've got a dropper and I'm adding drop by drop of a clear, colorless solution. So it's a solution. And this is also a solution. And a solution, just to remind you, is something dissolved into something else. And when they mix, they form a solid that wasn't there before. You can tell that it's solid because it's cloudy. So it doesn't dissolve back into the solution. So production of a precipitate is when a solid is formed from the mixing or from two solutions mixing. So that's a precipitate. And it's a new chemical that wasn't there before. Now, the last sign or indication of a chemical change is temperature change. Now, I put little asterisks next to this one because it should be noted that this alone would not necessarily be an indication of a reaction or a chemical reaction. But certainly, if you see any of the other signs of a chemical change and there is a temperature change, then for sure there was a chemical reaction taking place. It should also be noted that when I say temperature change, I don't mean that you added heat or that you removed heat. So it's not boiling or melting or things like that. It means that you've mixed two chemicals or you've reacted to chemicals and on its own it produced heat. So, we could talk about something like this. When you light a match, it produces energy. You didn't put that energy into it. It just made its own energy. That's definitely a temperature change. So finally, to review, physical versus chemical changes. Chemical changes, remember, they're not very easily reversed. New products are formed. The reactant, which are the chemicals that go in, are used up because the bonds broke and the atoms rearranged to produce our new substances. Often you'll see these different signs that a chemical reaction might take place or is taking place, like production of heat, light, you get fizzing because gas is produced, you might get a color change or a precipitate formed. Now, physical changes are pretty easy to reverse. If you melt an ice cube, you can refreeze it very simply. You're not getting any new chemicals forming. Often it's just a change in matter.